Good afternoon and have a good day to Dr. Tiang. My name is Hanis Amani binti Muhammad Yusuf. My matric number is 181091223. I'm from Group 1, course Archaeology and People Engineering. So today, I want to present my project for subject EE2208, Electrical Power Technology. The title of my project is Active Power and Parameter Measurement of Three-Phase System. As an electrical engineer, I need to construct the given electrical system that consists of a three-phase Y-connected generator, transmission loss, and a load with a certain power factor 0.9, which is lagging according to Electricity Supply Application Handbook V3. The load is supplied from a three-phase Y-connected generator at a line voltage with frequency 50 Hz. So the phase sequence is positive. So, what is a three-phase system? Three-phase system is the system which has a three-phase. In the system, the current will pass through the three wires and there will be one neutral wire passing the fault current to the earth is known as the three-phase system. In other words, the system which uses three wires for generation, transmission, and also distribution is known as three-phase system. The three-phase system is also used as a single-phase system if one of their phase and neutral wire is taken out from it. So the sum of the line current in the three-phase system is equal to 0 and their phases are differentiated at angle of 120 degrees. So what is advantages of a three-phase system? The three-phase system has several advantages like it requires fewer conductors as compared to the single-phase system. It also gives the continuous supply to the load, so the three-phase system has a higher efficiency and minimum loss. The three-phase system induced in the generator, which gives the three-phase voltage of equal to magnitude and frequency. It provides an uninterruptible power. If one phase of the system is disturbed, then the remaining two phases of the system will continue supply the power. The objective of this project are to investigate and analyze the electrical system formation, to evaluate the parameters of the electrical system, to evaluate and analyze the active power absorbed by the load by using two watt-meter method and also the conventional measuring method. In methodology, from the beginning, this project was assigned by the lecturer to Google Classroom. So I tried to find the ideas on Google and also from a lecturer that have provided. So after getting an ideas, I start to determine all the parameters obtained in the project, such as find phase voltage source by calculation using the phase voltage formula. Next, the value resistance and reactance of the load for transmission loss and for load is obtained by using my metric number. So here, my metric number is 181091223. So the number 81 in my metric number is as A, 09 as B, 12 as C, and 23 as D. So my Z line is equal to 23 plus J12, and my Z load is equal to 81 plus G9. After that, I start construct the three-phase YY connected circuit and run the circuit simulation by using PSIM. After running the simulation, I do the calculation for all parameters to compare the value obtained from a simulation with my calculation. I've made the discussion to evaluate and analyze all the parameters obtained. After all, I prepare the project report as my evidence to my project. Once finished, I submit the report with the zip file that I have attached with my circuit simulation that I have been done. So as a result in this project, I've done the calculation to find all parameters. Line-to-line voltage is equal to 132 kilovolt as given in the appendix. So to find a phase voltage, I use phase voltage formula. Phase voltage is equal to a line-to-line voltage divided by Z3. Line-to-line voltage 132 kilovolt divided by Z3. So the phase voltage that I get is equal to 76.21 kilovolt. Since the voltage phase is equal to voltage phase at load, so I can find the current flowing in this three-phase circuit by using formula current is equal to a voltage phase at load divided by a total impedance, which is impedance at a line and at load. So I got the value of current for IAN, IBN, and also ICN as shown in the slide. Since line current is equal to phase line current, so IAA is equal to IAN, IBB equal to IBN, and ICC is equal to ICN. For neutral, current IN is equal to 0 since it is the total of a line current in the system. To calculate a voltage drop percentage, we need to find voltage load at A, B, and C by using Ohm's law. So voltage load is equal to current times with impedance at load. After calculated voltage load A, B, and C, the value is equal to 58.54 kilovolt. Now I can calculate the voltage drop percentage by using formula. So voltage supply minus voltage load, as I mentioned just now, divide with voltage supply. To get the value in percentage, we need to time with 100. So I get the voltage drop percentage value 23.19%. Next, I calculate the active power absorbed by the loads using a 2 wattmeter method by using the formula as shown in the slide. Active power equal to a voltage load times with a current at load cos phase angle. Then I can find the total active power at load by adding three values of active power A, B, and C, which I get the value 125.37 megawatt. I also calculate the active power absorbed by the load using a conventional measuring method. The formula is total active power is equal to 3 times a voltage load time with current load cos a phase angle. The total active power is equal to 1 to 5.37 megawatt, which is same to value watt meter method. In discussion, you can see the difference between the line-to-line voltage given in the appendix 132 kilovolt with the line-to-line voltage simulated for VAB is a 101.29 kilovolt, VBC is 100.90 kilovolt, and VCA is 101.27 kilovolt. The magnitude of current flowing in the three-phase calculated is 718.29 ampere, which is slightly different with the value obtained from the simulation for IAA, which is 718.41 ampere. IBB is 713.74 ampere, and ICC is equal to 712.97 ampere. Then the voltage load calculated is 58.54 kilovolt. It's also slightly different with the value obtained from a simulation. Voltage load at A equal to 58.55 kilovolt. Voltage load at B equals to 58.34 kilovolt, and also voltage load at C is equal to 58.32 kilovolt. The active power absorbed by the load is calculated by using two wattmeter method and also conventional measuring method. The active power for both methods is same, which is 1 to 5.37 megawatt. So the total active power for two wattmeter method from a simulation is 1 to 4.46 megawatt. It shows slightly different to the value calculated. The total active power for conventional measuring method from simulation is 1 to 4.47 megawatt. It is also show the slightly different to the value calculated. The voltage drop percentage is calculated by using a formula as I have mentioned before. The phase voltage load is calculated to apply in the formula. So the voltage drop percentage is 23.19%. By doing this project, I can conclude that the electrical system formation is investigated and analyzed in this project. So all the parameters of electrical system is evaluated by using a calculation and a simulation program. So the total power absorbed by the load is obtained in this project by using two wattmeter method and a conventional measuring method. So overall, in this project, the three-phase Y-Y connected circuit in this project has successfully analyzed. So last but not least, I would like to thank you for your interest and draw my presentation to close. So thank you so much for watching this video.